Hey guys, I told you we would go over your spiral review that I sent you. So I'm going to go over 1 through 4 on this video, and I'll create another video for 5 through 8 and so on. So looking at number 1, which lines are parallel? I don't know about you guys, but I always use those 2 L's in the middle as a reminder to me of what parallel lines look like. There are 2 lines that never get any closer or never farther apart. I always think of railroad tracks. So which of these looks like they would never touch? Well, these are touching. If this one kept going, it would touch. These will never touch. So our answer is A. For number 2, these triangles are similar, and I reminded some of you that similar means they change by the same proportion. So we're looking at how does 5 change to 10? By what proportion? By being multiplied by 2. What is 3 times 2? It is 6. And you'll notice these are our corresponding sides to our triangles. So we're going to do the same thing to 4. 4 times 2 is, that's right, 8. So our answer is A. Okay, let's look at number 3. We've got another triangle, and I reminded you that this is red. The measure of angle X equals 25 degrees. So this angle here where X is marked is a 25 degree angle. Well, let's look at our answer choices. That angle, would we say it is a right angle when we know that right angles are 90 degrees? Can we say it is a right angle? No. What do we know about acute? Acute angles are smaller than a right angle. So is 25 smaller than 90? Yes. Obtuse means larger than a right angle. So is it larger than 90? No. The only answer that works here is acute. So our answer is B. For number 4, again, we're dealing with triangles that are similar. So they're changing by the same proportion. Okay. These triangles are equilateral triangles, meaning all 3 sides are the same length. If all 3 are 5, the length of 5 on this triangle, then all 3 on this triangle are going to be 20. Very good. So Z is 20. Okay, I hope you did well on this as you checked your work. Make sure you make any corrections that you need to. Tune in to the next video. Okay, guys, let's go over 5 through 8. For number 5, we have a right triangle, and we know that because of the little square in the corner. And we're going to use Pythagoras' theorem. A squared plus b squared equals c squared. They've already plugged in the measurements that were given. A, we don't know. B, they plugged in 8 because that's the measure of the other leg. And C, they plugged in 17. That is your hypotenuse, the longest side. So how would we go about solving this problem? We can start by simplifying what we have. We know that 8 squared, or 8 times 8, equals 64, and 17 squared is 289. So we're going to get rid of our 64 now so that we can get A by itself. Subtract 64 from both sides. We're left with A squared equals 225. And then, of course, to get rid of the square, we have to do the inverse, which is the square root. So we'll square root both sides, and the square root of 225 is 15, because 15 times 15 equals 225. And A is our first answer. For number 6, we have 2 triangles. We can tell by looking at them that they're not the same size. but we can look at the angles to tell if they are the same shape, the same type of triangle. So let's look at our measures of the angles: 70, 70, 80, 80, 30, and 30. If the angle measures are the same, then these two triangles are similar because they changed in size by the same proportion. Congruent, we know they're not because they're not the same size. And neither would be if the size and the shape both were different. Number 7, we have two triangles that they already tell us are similar, so we know that they're changing by the same proportion. The side we're wanting to know the length of is EF. That side is corresponding to BC on the other triangle, and we know it is 4. But we need to know what proportion this triangle changed by in order to determine the size of this length of this one. So let's look at two that are given. We know this side is 5. The corresponding side we don't know. This side is 7, and we know the corresponding side is 3.5. So how did 7 change to 3.5? So 7 times 1/2 equals 3.5. So we're going to apply the same rate of change, the times 1/2, to our 4. 4 times 1/2 equals 2, and our answer is A, 2. For number 8, we're looking at a square that has been divided into two triangles here by drawing a line diagonally through the middle. We're wanting to know what this equation would equal. So we need to know what is the measure of BAC. So let's trace our line, BAC. Then we need to know the measure of this angle. We already know this is a square and all of the angles in the corner are 90 degrees. So we know that one is 90. Okay, we are going to look next at ADB, AD to B. So we need to know this one, and it is labeled. It is 45. Then we're going to go ADC. This one's not labeled, but we know that 45 plus 45 equals 90. So we're going to plug in our 45. When we add 90 plus 45, we get 180. So our answer is 180. Okay, tune into the next video for questions 9 through 12. Hey guys, let's go over questions 9 through 12. All right, so we're dealing with a triangle here, and it wants to know what is the value of x. Well, we know that each of the three angles on a triangle add up to equal 180 degrees. So let's put in what we know. We know that this angle is 55 and this angle is 63, so we plug them into our equation with x to equal 180. Okay, our 55 and 63 can be added together to give us 118. 118 plus x equals 180. And then we will subtract 118 from both sides, leaving us with x equals 62, and our answer is A, 62. For number 10, we have a right triangle. We know it from our square in the corner. And we're going to use Pythagoras' theorem to solve it. A squared plus b squared equals c squared. So let's plug in what we know. We know that a equals 2 and b equals 5. So 2 squared plus 5 squared equals c squared. 2 squared is 4. 5 squared is 25. 4 plus 25 is 29. So 29 equals c squared. We know that we have to take the root of both to get rid of the square here. So our answer is the square root of 29. For number 11, it tells us that each of these lines are parallel to one another, and it's asking us for the measure of angle V. This is angle V. And I drew my circle because I'm reminded that those four angles, we can just move them down and they equal the same as those four and those four. I'm looking for the one that would be in the same position or would be a corresponding angle to V. If I move that circle down here, V and W are in the same place. Those are corresponding angles and they are equal. So my answer is A. For number 12, DE is this line, and I know it is 20 feet long, so I'm going to go ahead and plug in a 20. And then I need to know line AB so that I can subtract it. AB. Since the measurement for this line is not given, I'm going to have to figure it out. It happens to be the diagonal or hypotenuse of this right triangle. And I know this is a right triangle because I see my little square in the corner. So I can use Pythagoras' theorem to figure it out. When I plug the numbers into my formula, a squared plus b squared equals c squared, I have 6 squared plus 8 squared equals c squared. 6 squared equals 36, and 8 squared equals 64. 36 plus 64 equals 100, which equals c squared. I just need to know c. So I will take the square root so I can get rid of this square and it will give me my c. And I know that 100 squared equals 10. So I can plug that into my equation, and 20 minus 10 equals 10, and my answer is C. Okay, now we're ready to do 13 through 16. I have written my Pythagoras theorem at the top here because I recognize this as a right triangle. I've plugged in the numbers that I know. So I have 3 squared plus 10 squared equals c squared. 3 squared equals 9, and 10 squared equals 100. 9 plus 100 equals 109. And I know that I'm going to have to take the square root in order to get rid of this square. And luckily, my answer choice is already there from this step. So my answer is C. Number 14, again, is a right triangle, so I'm going to use Pythagoras' theorem. I've written my equation, and I've plugged in the sides I know. You'll notice I still call it C, and they're calling it H. The letter or variable does not matter as long as you understand the hypotenuse is always your longest side. 4 squared equals 16, and 7 squared equals 49. Now, I know in order to get rid of my square, I'm going to have to take the square root of both of these sides. And normally, I would add those two together before doing that. But I noticed in my answer choices that I do not have a single number down here or a single number inside a root symbol. So I left it as my two numbers to be added. 16 and 49. And if I look down here under my square root, I see 49 plus 16. And we know that you can move those around when you are adding, and it will not change the amount. So my answer is B. For number 15, do not let all the extra get you confused. This skier is just reminding you this is a slope. Or a diagonal line here. We're still going to apply Pythagoras' theorem. So I'm plugging in the amounts I know, the 100 squared and the 200, and square that as well. So 100 squared equals 10,000, 200 squared equals 40,000, and when I add the two together, I get 50,000. Remember, to get rid of this square, I'm going to need to take the square root of both sides, And so my answer is the square root of 50,000, which is C. For number 6, since these triangles are similar, I know that they're going to change by the same proportion. The side lengths are going to change by the same proportion. This side length and this side length are both given, and they're both corresponding. So how does 5 become 10? By being multiplied by 2. So I'm going to multiply all of my sides by 2. 3 times 2 is 6, and 4 times 2 is 8. And I am only needing this side, so my answer is B, 6.